So we are going to substitute them into the equation to get. So we know them. So we know force DEM, force DC. So we are going to substitute them. So we are going to get negative force EC to be, what is force? Okay, we know force EC to be 50. So negative 50 minus force EB sine theta. So here we know force ED to be minus negative 88.88 sine theta will be equal to 0. So here we are making force E be the subject, so it will cross the equal to sign to be positive. So let's bring this one down. Negative 50 minus 0.88 sine theta, and this one will cross the equal to sign to be positive E B sine theta. So here we know theta to be 50 minus negative 88.88 sine 36.87. So EB sine 36.87. So this one will be 33.328 equal to this one, force ED sine 30. So we divide both side by sine 36.887. Okay, sine 36.87. They will cancel. Then we're going to get sine 36.87. So force EB will be equal to 10.28 all over sine 36.87. So force EB will be equal to 5.55 kilonewton. So it is positive. So it will be under tension. So force EB will be equal to 5.55 kilonewton tension. So from here we can substitute these ones into equation 1. So let's state equation 1. So equation 1 is negative force EF plus 80 minus force E equals theta plus force. So there's it. So you are going to substitute them into it. So no negative force E plus 80. We know force ED to be 5.55. So minus 5.55 cos theta is 36.87 plus you know force ED force ED to be negative 88.88. It didn't bring the negative sign because we have brought compression here, meaning it is negative. So that's negative 88 point negative 88 cos theta is 36.87 count 0. So yeah, this one will cause the equating sign to be positive F E. Then you bring this one's 80 minus 5.55 cos 36.87 plus negative 88.88 cos 36.87. So you're going to punch these ones on the calculator to get 4.46 kilonewton. So F will be equal to 4.46 kilonewton. It is positive, so it will be under tension. So we're going to get 4.6 kilonewton and bring our tension. So that's it. So from here we can take another joint. So let's take joint F. Let's take joint F. So from here we know this angle is equal to this angle here, 36.87, and it is equal to this angle here to 36.87. So okay, so here this angle and this angle are alternate angles, so they are the same. So we are going to get 36.87 here. So from here to here is 90. So 90 minus 36.87, we are going to get here, or let's take here to be beta. Here, no, we are going to get here to be, or here will be 53.13. Yeah, here will be 53.13. This angle. Okay, so let's draw F B D of joint F. Going to get here will be force F E. Yes, F. So force F E. So force F E. So here will be force F B. Here too will be force F A. And here will be beta, which is equal to 53.13. So let's assume here to be A, here to be B. So from the previous ones, we got force EF, or force FE, to be equal to 4.46 kilonewton. Force EF equal to 4.46 kilonewton. This is under tension. So sum of forces along the horizontal axis. So I'm going to for sum sigma f of s will be equal to 0. So we have this one, which is force Fe, and it is pointing to the right. It is positive. So F force Fe positive, and for every inclined force, it has both this thing, horizontal component and vertical component. So we're going to deal with the horizontal component, which is A. Horizontal component is this, and its hypotenuse. So the horizontal component is the opposite of this angle, which is A. So we are going to get opposite and hypotenuse. Opposite and hypotenuse to be, let's take so ka to. So opposite and hypotenuse for under so we're going to get sine theta will be got opposite over hypotenuse. So the opposite is A, so A hypotenuse sine theta. So from here we are going to make A the subject. A will be equal to sine, will be equal to, no, the hypotenuse is, sorry, didn't bring the hypotenuse. So sine theta will be equal to A over hypotenuse is force Fe, force Fe. So A will be equal to force Fe sine theta. So we are going to substitute them into the equation. So it is pointing to here, to the other side, which is going to give you negative. So negative force Fe sine beta. Here is beta, sorry. Sine beta. Because we are dealing with this angle, it is beta. Yeah, equal to 0. So from here, we know that force EF was 4.46 kilonewton. So we can substitute it into it. 4.46 minus force Fa sine beta was 53.30. So this one, of course, they equal to sine. We're going to get force Fa sine 53.13 will be equal to this one. We are going to bring this one 4.46. So this one will cancel each other. Sine 53.13. So force F will be equal to 4.46 over sine 53.13. So force Fa will be equal to 5.58 kilonewton, and it is positive, so it will be under tension. So 0.8 kilonewton to be under tension. Force Fa. So that is what you get.